Okay, so this took a little longer for me to get to, but I finally got to it. So let's take a look at it. First, we're going to look at like distributing those cones across those lofts across these lines. And you've already done this, but I'll run through how I'm affecting them. Changing where things are and all that kind of stuff. I added a little bit of something in there. But let's take a look at what we've got. So basically, I've taken these three curves here and put them in these little containers, right? So let's look. You can see that that's that one, and that's that one. And then I've divided them, right? So if we look at these guys, we just get a division based on the number, and that's what I'm going to use to start the polygons with, right? And so I don't really need this one. And then what I do is I just merge all those points together. So if you look at a panel, right, I'm just putting them all in a little stack right here. So there's 13 of them, right? And then I'm starting to affect how the radii of the polygon. So here's the polygon, the very first one we're going to do on the Y. And what I'm going to do is I'm actually going to use this domain and range and so it's not the same size polygon every time. You can use this domain and range and create and jitter to create variation. So if we look at what's happening is right now we have a domain and a range of 2.9 to 4.6, and so that just gives you those two numbers. And then the number, what I want is I want it to just give me a series from 2.9 to 4.6 with the number that's counting the length of the points that I have, right? So I had 13 points. I have to do a -1 because of the binary way that that Grasshopper counts. So it'll actually give me, if I get, if I divide at a certain amount, it gives me 1 extra if I just take the list length of this guy. So what happens is we get this domain, we say we want this number, and then it will punch out 12, right, or 13, right, of those numbers between that range, and then they're all in order. So this little jitter just goes in and shakes them all up into a different order so they're not in order, and I put those into the polygon radii, right? So if I do a preview, you can see that the polygons are all a different size, and if I start playing around with this, they'll get smaller or larger, right? The range changes, so you can then have some variation very quickly, right? So so that's kind of the method, and I used it in several different places. So there's the original polygon, and here's the move for the Z, and I did another jitter, right? So if we look at the move for the first polygon, they're moving up in the Z, but you can see they're all moving in different, between 8.4 and 30 feet, right? Oh, we don't need this. Right, and so we also did it for the offset for the P2. So if I do the preview, it's doing a little offset for this guy. So based on the jitter, yeah. So the difference in the sort of offset between these, it's not a whole big bunch, but you could go in and see the difference if I made it bigger or smaller. And then we go through several of these. So there's a Y offset as well, and then the P3 offset, right, for the overall. So if I preview that, that's the, and then this guy gets moved in the Y as well, so it gets jittered in the Y, and I used an actual negative number, so it'll go back and forth for that one as well. And then that just gets again pulled up to the surface. So if I preview that, and let's preview off all this stuff, right? Those three main ones get pulled into this entwine here, and the surface, if I preview that, right, is this guy right here, and that gets pulled onto the surface just like we did before. And then we take, you know, the first polygon, the second polygon, and the third polygon, and we entwine them. So that gives us a list of lists, right? So if we come and take a look here, that just gives us, you know, all 13 of the curves in order. Now if I tried to loft these, it would try to loft all the ones on the first level and then all the ones on to the ones on the second level. So what I have to do is I have to flip the matrix. So if I Control C, Control V, oops. Okay, so let's shorten this guy up and let's just do a panel here. So if we flip the matrix, what that does is instead of giving us columns of 13, it flips them and gives us columns of 3. So instead of 3 lists of 13, we get 13 lists of 3, right? And so that means it's going to loft these guys all individually. So we do that, and then we get this, and we get a preview, and then there's your lofts happening, right? And then you can of course go back and adjust any of these. So like if you wanted less guys, you could give less points or more points on this guy so it gets denser in particular areas, right? And it'll just continue to update those. The other thing that I did do as well, if you want to look at it, is I actually like you can create a solid with these guys. So let's turn that off and let's turn off the surface. So what I did was I took those lofts and capped them and then joined them. I split the surface out. So what this does is it takes the intersection of all of the curves and the surface and it splits them. So let's go ahead and preview that off. And then if I go and take a look at this and preview that, it just splits the surfaces out. And then you can join that with the lofts, right? You can cap the lofts. So if I preview that, that's the lofts capped. And then you can join that, right? And you get individual little pieces. It had a problem Boolean unioning them in here, but you can bake them. And then let me go ahead and turn this off because it's going to be different. And then you can Boolean union them once you get them, you know, kind of back. Let's see if it'll do that one. Let's see. Boolean union, that, and that. Right, and once you get that in there, you could actually union them into a big solid, so you have all of your lines and you can do a section and all that kind of stuff from it. Okay, so that's that one. When I come back, we'll talk about the surface one.